Hi, Assalamualaikum and good day. Today you are going to learn on how to solve the first order ordinary differential equations, or in the short form ODE. These are the objectives of our lesson. Hopefully, by the end of this session, you are able to 1. Understand some basic concepts and definitions concerning differential equation, and 2. Identify and solve first-order ordinary differential equations, or in the short form ODE. Differential equation can be classified into two, which are ordinary differential equation, or in the short form ODE, and partial differential equation, or in the short form PDE. Basically, differential equation is an equation that involves an unknown functions and its derivatives. For ODE, the unknown function depends on only one independent variable. For example, dy over dx equal to 5x plus 3. Here, the unknown function y depends on only one independent variable, which is x. As for PDE, the unknown function depends on more than one independent variable. For example, d square y over dt square plus 4 dy over dx equal to 0. Here, y depends on two independent variables, which are t and x. In this chapter, we will only focus on ordinary differential equation. Order of ODE is referred to the order of the highest order derivative that appears in the equation. For example, if given dy over dx as the highest order derivative in the equation, then the equation is said to be first order ODE. If given d square y over dx square as the highest order derivative in the equation, then the equation is said to be second order ODE. Let's refer to example 1. You need to state the type of the following differential equation. Equation A and B are said to be ordinary differential equation, or ODE, because the unknown function y depends on only one independent variable, which is x. As for equation C, it is known as partial differential equation, or PDE, because y depends on two independent variables, which are t and x. Let's proceed with example 2. You need to state the order of the following differential equation. A is referred to second order ODE because the highest order derivative is d square y over dx square. B is referred to first order ODE because the highest order derivative is dy over dx. As for C, when you rearrange the equation, you will notice that this is referred to first order ODE because the highest order derivative is dy over dx. And for D, this is referred to second order ODE because the highest order derivative is d square y over dx square. To solve the first order ODE, first of all, you need to check the types of the equation, whether it is separable, homogeneous, or linear equation. The first order ODE is separable if we can separate the variables. For example, if given x and y in the equation, if we can move all the y terms to one side and all the x terms to the other side, that means it is separable. If the equation is not separable, you need to check whether it is homogeneous or not. That is by checking whether f dx dy is equal to fxy, which is equal to dy over dx. If the first order ODE can be represented in the form of dy over dx plus pxy equal to qx, then the equation is said to be linear. Following are the steps to solve the first order ODE, which is separable. First, you need to separate the variables by moving the x to one side and y to the other side. After you separate the variable, next is you integrate both sides. Refer to example 3. You need to solve the differential equation. Replace the y prime with dy over dx, then separate the variable. You should obtain 3y dy equal to 2x dx. Integrate both sides. You should obtain 3 over 2y squared equal to x squared plus c. Now, refer to example 4. You need to solve the following differential equation. Replace the y prime with dy over dx, then separate the variables. You should get 9y dy equal to negative 4x dx. Integrate both sides. You should obtain 9 over 2y squared equal to negative 2x squared plus c. Refer to example 5. You need to solve the following differential equations. To solve A, you need to separate the variables first by moving all the y terms to the left and all the x terms to the right, then integrate both sides. You should get the following answers. To solve B, you need to apply the same procedure. Separate the variable first, then integrate both sides. You should be able to get the following answer. What should you do if the equation is not separable? You need to determine whether the equation is homogeneous equation or not. That is by checking whether ftx dy equal to fxy. If the given equation is homogeneous, these are the steps to solve it. First, you need to substitute y equal to xv and its derivative dy over dx equal to v plus x dv over dx into the equation. Then, obtain the new function in terms of v only on the right side. Next, separate the variables and integrate both sides. Finally, replace the v to y over x. Refer to example 6. You need to determine whether the given equation is homogeneous or not. By letting fxy as dy over dx, to obtain ftx dy, you need to replace all the x with tx and all the y with ty. Make sure you bring along the bracket to avoid careless mistake. Then simplify your answer. As the answer is equal to fxy, which is also equal to dy over dx, therefore we can conclude that this equation is homogeneous equation. Let's proceed with example 7. You need to solve the following differential equation. This equation is not separable, so you need to check whether it is homogeneous or not. Before you check whether the equation is homogeneous or not, you need to represent it into the form of dy over dx. There is an easiest way to determine whether the equation is homogeneous or not. That is by looking at the total power for each term. If all the terms having the same power, that means the equation is said to be homogeneous. For example 7, as all the terms having the same power, which is 1, this equation is said to be homogeneous. To solve, let y equal to xv. Then dy over dx is equal to v plus x dv over dx. Substitute both information into the given equation of dy over dx. Then simplify the function on the right. You should get the new function in terms of v only. Next, move the v that you have on the left to the right and simplify the function on the right once again. Then separate the variable and integrate both sides. To integrate the function on the left, you need to apply u substitution. Let u equal to v squared minus 2v minus 1. Differentiate with respect to v, you should get 2v minus 2. Substitute this into the integral and simplify. You should get negative 1 over 2 ln u. Replace u with v squared minus 2v minus 1. Replace the v back to y over x, you should get the final answer is negative 1 over 2 ln y squared over x squared minus 2y over x minus 1 equal to ln x plus c. Now refer to example 8. You need to find the solution to the given differential equation. Before you solve, you need to identify the types of equation first, whether it is separable or homogeneous. Represent the equation in the form of dy over dx. As all the terms having the same power, which is 3, this equation is said to be homogeneous. To solve, let y equal to xv. Then dy over dx equal to v plus x dv over dx. Substitute this into the equation of dy over dx and simplify the function on the right. You should get the new function in terms of v only. Next, move the v on the left to the right and simplify the function once again. Then separate the variables and integrate both sides. To integrate the function on the left, you need to apply u substitution. By taking u equal to 1 minus 5v to the power of 3, differentiate u with respect to v, the answer is negative 15v squared. Substitute this into the integral and simplify, you should get negative 2 over 5 ln u as the answer. Replace the u back to 1 minus 5v cubed. By substituting all the v with y over x, you should get the final answer, negative 2 over 5 ln 1 minus 5y cubed over x cubed equal to ln x plus c. Take note that for homogeneous equation, you should always get the same answer on the right, which is ln x plus c. The only difference is the answer on the left, depending on the given equation. What should you